Hey Algebra, here are the notes for 6.2, Understanding Inequalities. So first off, how would you expect to solve the following inequalities? Well, the easiest way to do this one is obviously to just divide both sides by 4 to start off with. When we do that, we get x is greater than 2. Actually, I'm going to type that one because it's a little bit faster. X greater than 2. And when we check this by plugging in the value of something like 3, check with 3, we get 12 is greater than 8, which is good to go. We are good here. We are happy with that. Excuse me. However, when we do the same thing over here, we get x is greater than negative 2. And when we check with a value that's greater than negative 2, like 0, we end up getting 0 is greater than 8, which is not a true statement. So what we have to do in order to get a true statement is actually to flip the sign when we divide it by a negative 4. Because if I flip the sign and I check with a value like negative 3, negative 3 times negative 4 is 12, and 12 is greater than 8. So why did we do this? Well, essentially, when we're multiplying or dividing by a negative, we are flipping the number line around. We are flipping it on its head. So the negative is where the positive was, and now the positive is where the negative was. So what we need to remember is whenever we multiply or divide by a negative number, we must flip our inequality sign. No ifs, ands, or buts about it. It has to happen. So if we started out with something like this, with a greater than, must change it. We have to change it to a less than. If we started with a greater than, it must change to less than. And same thing with the less than or equal to and greater than or equal to. If it starts out with a line underneath it, it has to end with a line underneath it. So let's solve the following and graph these. Well, 15x is greater than 75. We divide both sides by 15. We get x is greater than 5. Now this graph is pretty normal. We're used to this one because we saw a lot of it yesterday and practice it. We put our mark at 5. We put a ring on it because we care about that value. We draw our arrow in the correct direction. Notice my little trick here is that this arrow is going that way, so is this one, so I'm good to go. And I don't need to fill it in because there's no or equal to on this one. This one's one we're used to. How do we solve this one? Well, if m is being divided by 3, we need to multiply both sides by 3. When we do that, we get 9 less than m. I don't really like this. I don't like when the m is on the right-hand side. Sometimes it confuses me. So what I'm going to do is put the m on the left-hand side, but I'm going to flip the sign with it because if the m goes over, I have to make sure my m is still greater than 9 like it was in my first equation. This also makes it easier to use my trick when I graph, because if I put my 9 on my number line and I do my little circle, now I can double check that that arrow is going the right way. All right, here's another one. Divide both sides by that negative 3. Except this time, because I multiplied or divided, let's jump up here actually. I divided by negative 3, so I must flip the sign. When we do that, we get m is less than negative 2. Now I don't graph this any differently. Just because I flip the sign doesn't mean that I change how I graph. My value that I care about is still 2. I still circle, and I still put the arrow going less because m has to be any values that are less than negative 2. All right, this one, divide both sides by 2. You get x is greater than or equal to 7. I don't like this form because the x is on the wrong side. So what I do is I move it to the other side, keep that inequality facing the right way. Some of you may think, well, why are you switching the sign if you didn't divide or multiply by a negative? Because in this case, I'm turning the whole equation around. I'm basically taking the mirror image over a dotted line and saying, instead of being in here, I'm taking it over here and making it look like this. So this is just the mirror image. I'm not changing the sign or how I graph it. So let's just quick throw that on a graph. What's different about this graph than the other ones I've done so far? Well, you'll notice that my arrow is still pointing to the right, and that's fine, but now I have this line underneath, and that's a dead giveaway that I need to put, I need to color in my circle, put extra color on it. I made the analogy in class. If you like it, you put a ring on it. If you love it, you got to fill it in with diamonds. That's what this little line underneath tells us, that we got to fill that bad boy in. All right. Last one, multiply both sides by -2, because right now it's being divided by 2, right? So we multiply both sides by 2. This is a multiplication dot. You can't really see it. So is this. And why do we do that? Because -2 divided by -2 is just a big fancy 1. So, excuse me, on the left side I'm left with x. I multiplied or divided by a negative though, so I got to flip that sign. And I'm left with -1 times 2 on the right. So my final answer is x is less than 2. Now I had someone ask me today, well, Miss Bury, the final answer is positive. That's okay. I don't care about the final answer. I care about the action that I took to get the final answer, which in this case involved me multiplying by a negative. All right, there's my dot. There's my arrow because I need all the values possible that are less than 2. All right, that's all there is. You now have homework. Good luck.